between curves, right?
Yeah. Okay.
Area between curves. Okay. So in the previous classes we have discussed about the area. Okay. Suppose this is a xy axis, and suppose you have a function. Okay, the function is y is equal to fx, right?
Okay.
Suppose this is some kind of a function, y is equal to fx. F is what? Y fx is what? Fx is, there is some function that is in the form of x, right? So
Yeah.
it could be x, right? It could be
Yeah.
square root x. Okay, it could be cube root of x. Okay, that is 1 by 3. Wait, let's take in x to power 1 by 3. It could be anything. That is, it should be the function of x, right? So suppose I have this function, I have this curve, and if we want to find the area, what will be the formula? Either there are two ways. If we know this shape, till now we have discussed so many types of calculating the area. So one of them is, if we know this shape, what we can do, we can draw a line, and suppose this is a point A and this is a point B, and we want to find the area between A and B. Okay, Kevin. So what we could
Okay.
do, either we could, if we know the shape, we can calculate the area of the shape. But since the function is this boundary is what? It is curved, right? If this shape would have been the triangle, we just apply the formula half the base into the height. Okay, and we can do that. Okay, we can calculate the area. But since this shape is what? Curved, right? So we don't know any known area of this shape, this complete shape. So then we introduce to the approximate methods, right, Kevin?
Okay.
In chapter number 5, we known to the approximated methods, and these are Riemann sums. Okay, using
Okay.
that we calculated the area, right? But still they were approximated methods, right? They were not, you cannot say they were very correct methods. Okay, so in the approximate methods, either what we could do, we could make a triangle from here to here, right? Okay, and then we can calculate the area of this particular part. That is a one approximate method, but still it's inaccurate because so much of area is left behind, right? Then we
Yeah.
got
Okay.
introduced to the Riemann sums. Okay, in that we make the rectangle strips either right or left or midpoint. Okay, but still those were the approximate methods. Those were not the exact correct method to find the area. Okay, then we got to know from the from the approximate methods, we got to know that we can do it mathematically by introducing the integral. Okay, what it is? Integration. Okay, so in the form of integration, what we could do, it is written as, if limit Riemann sum, if n goes to infinity. How we got to know the introduction from Riemann sum? If the rectangle strips, in the Riemann sum we take the rectangle strips, if they are taken to be infinity, okay, and their size is so small, okay, right? So it is called
Yeah. Okay.
fxi delta x. Okay, this could be called summation, and should not take n, we should take I is equal to 1 to infinity. Okay, then, right? So if we
Yeah.
take
Okay.
this, if we consider that if every function is very small and the distance between them is very small, okay, between the strip, then that becomes the integration. Okay, you could completely write from a to b fx dx. Okay, if these rectangle strips we take, if they start becoming so small, right, very small, the
Yeah. Okay.
delta x become what? For this, I should write here for this limit delta x becomes what? 0. Okay, almost 0, the length. Then it will become what? A to b fx dx, right? Fx dx. That delta x becomes dx. Okay, Kevin, you got this introduction?
Yeah. Okay.
Okay. So simply in the simplified manner, we can write it is equal to the area can be written as ax, okay, which is in the form of x from a to b. In that particular, in the very easy manner, you can write it from a to b. Okay, from the a to b, you write the function and then you write the dx. You do the integration, you will get the area. Okay.
Okay.
Suppose you have suppose I am giving you a to b. Okay, from giving to 0 to 1, suppose a is equal to 0 and b is equal to 1. Okay, a is 0 to 1, you need to go, and fx I am taking square root x. Okay, so you write square root x dx. You find the area, and that will be x to power 2 by 3, 3 by 2 plus c. Okay, now you put the values. It is 0 to 1, so it will be 2 by 3 inside 1 and minus 0. Okay, so it will be 2 by 3. That is the area, right? Okay,
Yeah.
so this is the way we calculate the area. Okay, getting my point?
Yeah.
But 6.1 is all about if we have just not one curve. Okay, it's not about just one curve. Like here we have discussed just one curve.
So yeah, 2 curves.
Yes, it is about 2 curves, not just one. But the concept will be same.
You take the area of the first one and subtract it by the area of the second one.
Exactly. Okay, so it is the like same method we are applying. Suppose if there are 2 curves, the curve one of is this and this is the second curve, right? And they are asking from a to b. Okay, suppose a is this, and b is here. Okay, b is here. So what will be the enclosed area? The enclosed area is this. Okay, so how we got to know that we have to subtract the area? So what we have done, we have just simplified this. Suppose this is fx and this is gx. Okay, there are 2 curves. So if we know the area a1 is what? From a to b, a1 can be written fx dx, right? Right, Kevin? Any problem in this?
Yeah. Okay.
But since it is a positive area, it can be written as positive. A2 is what? A2 is from a to b, we can write the same way. A to b gx dx, right? But it is a negative area or positive?
That's negative.
Negative, right? So we will write that a will be equal to what? A will be equal to a to b fx dx minus a to b gx dx, right? So can we write, since the limits are same, can we write like this? A to b, since the limits are same and the dx integrand is same, okay, it is same. So can we write it from a to b fx minus gx dx, right? Can I write that?
Yeah. Okay.
That is the final or net area you calculate if there are 2 curves. Okay, Kevin?
Yeah. Okay.
Okay, so this is the area you want to calculate, that is complete A. Okay, the red shaded area, that is you want to write, that is using this formula. Okay, Kevin?
Okay.
There is a note in this chapter. The note is this, that when you find the area, you have to decide which one is to be taken as a greater and which one is to be taken lower. Okay, that like they always will not be like gx will not always be in this region. Okay, it could be anywhere. Okay, so there are methods like how will you
can you go back to the previous slide? I need to copy something.
Sure.
Okay, yeah, I did it.
Okay. So how will you decide that which function has to be bigger and which has to be lower, right? So there are methods. Methods are, if fx has to be greater than gx, if fx has to be greater than gx, then area will be written what? A to b fx minus gx, right? And dx.
Okay.
Okay, this will be the formula A. But if gx is greater than fx, then A will be written as, from A to B, g of x minus f of x dx. Right? Right, Kevin?
Yeah. Okay.
Now, how we will decide that which function is greater and which function is bigger? That onto a given axes, okay, x and y, if we have some value, suppose function is having greater values of y. If function is about, like, I should write, okay, if function is into the form of x, okay, into the form of x, then you have to take y, which one is having y value greater, okay, that
Okay.
function
Yeah.
will be considered greater. Suppose this is the example of these are the curves, okay, and this is gx, right, Kevin?
Okay.
Right?
Yeah.
So which function is having more values, more y values or greater y values? Function fx or gx?
Fx has
Fx,
greater
right?
y value.
See,
Yeah.
greater y values, right? And it is lesser y values. The highest value it is taking gx, that is here, okay, and the greatest values fx is taking, that is here, okay. So it means fx is having greater values, so it will be considered as greater. So fx will be greater than gx here, okay. That is if function is in the form of x. Function is in form of x, right, Kevin?
Yeah.
Okay.
Yeah.
But if suppose you have a function here xy and function is in the form of y, okay. Suppose if
Okay.
if this considered as fy and if this is considered as gy, okay, and you have to calculate the area of this region to this region, okay. So this will be the area, right?
Yeah.
Okay.
Okay.
So which function you will consider greater and which function
Yeah.
lower?
So like if you flip it 90 degrees, then you
Don't do
take
that.
the biggest.
Don't do that, Kevin. No, that's not the method to find it. Okay, in that case, I have told you.
But then it becomes a function of y instead of x, right?
Yes, it. No. I'm not saying that. I'm just saying, how have you decided here? The more function is having y values, greater y values, that is
Yeah.
bigger, right? Same way
Yeah.
here. The more it is having x values, the more it is having
Yeah.
x values. Which function is that? Fy or
That's
gy?
fy.
Exactly. Okay. So for the trick, if the function is in the form of fy, you just take the rightest one. Which one is it? Fy. Okay. So here
Okay.
fy is greater. Don't flip that. That can confuse you. Okay. When the function is in the
Okay.
form of x, okay, it is having more y values, that is greatest, okay, or the bigger. If it is having on the xy axis, if the function is in the form of y, then you take which is having more x values. Okay. Fy is basically what? Tell me fy. What it is? Fy is basically x, right? X is equal to fy.
Yeah.
Okay. So it will be x values, right? That you are getting.
Yeah. Okay.
Okay. And if you have fx, so y is equal to fx. So what that does it mean? It means you are getting more y values, right? So y values ultimately you are getting. Is that clear, Kevin?
Okay. Yeah, I think so.
So here you will write a is equal to, since fy is greater, you write a to b fy minus gy. Okay, since the function is in the form of y, so what will be the integrand? Dy. Always remember, you have made some mistakes regarding this. So it will be dy, not dx. Okay, is that okay, Kevin?
Okay. Yeah, I
Okay.
think so. Yeah.
Okay. Any doubt till now?
No.
Okay. So that is just the introduction of your 6.1, and there is nothing in this. Okay. If you suppose this is the like, if they haven't given you the graph, then how will you decide that which function is greater and which function is lower? They will be given you some values of a and b. Okay, they must have given you some values of a and b. So what you could do, you could find some middle points of the a and b, at least 3. Remember, at least 3, not just onto the boundary. First you check on the boundaries if they are coming same. Okay, if they are giving same values on a and b, then you find at least 3 middle points. Okay, and on those check it. Okay, then you can check which function is getting y values greater or x values greater. Okay, so at least 3 middle points choose. Okay, and then corresponding to that, corresponding xy values, and then check corresponding y values, x and y values. Okay, to decide which function is greater. Right, Kevin? Getting my point?
Yeah, I got it.
Okay. So I'll start with the questions now, because this is the introduction. There is nothing else in this chapter. If you get these all the parts, all the concepts that I told you right till now, that is it. You can do 6.1. Got it, Kevin?
Yeah.